Wings of Russia Studio presents Wings of Russia documentary. November 1950. The war in Korea is on its way. Huge UN forces led by the United States act on the side of the capitalist South. A group of American F-80 Shooting Star fighters take off for a combat mission. Confident of their superiority, pilots do not expect any enemy attack.
Contact now, 30 degrees left at 25.
All of a sudden, 3 silvery aircraft appeared in the sky attacking American fighters at high speed. The MiGs were superior in speed and maneuverability, and they soon shot down one of the shooting stars. The remaining American fighters quickly left the airspace of North Korea. That was the first in history air fight between jet aircraft in which Soviet pilots were victorious. A fighter is designated to have superiority over aircraft of any other class. Maneuverability and efficient armament are among its obligatory qualities. However, speed is one of the most important components of success. In order to reach it, throughout the fighter's entire evolution, designers were installing more powerful engines, updating aerodynamics, introducing different technical innovations. During the Second World War, the maximum speed of serial fighters significantly increased. However, the engine weight was way ahead of the power-to-weight ratio increase. Moreover, the propeller is capable of bringing aircraft only to a certain limited speed. Scientists and designers of the world-leading aviation countries acknowledged this problem almost simultaneously. The way out was found in the creation of a principally new type of engine. The working principle of such engine gave it its name, the jet engine. Here is how the concept was explained in a training film of 1947.
Посмотрите, как откатывается пушка при выстреле.
Look how the gun barrel recoils after the shot.
Газов из ствола пушки.
This blowback feature of the firing arm makes the basis of the jet motion principle. If we take the barrel off the mount and put it on stabilizers, we shall have a primitive flying jet unit.
Мы получим простейший летательный аппарат с реактивным двигателем.
In hope of luck, research was conducted in several directions at a time. The main of them was with respect to the liquid propellant rocket LPR engines and the turbojet engines. In the LPR, working gases are created in the combustion chamber due to the chemical reaction between fuel and oxidizer available on board the aircraft. In the turbojet engine, air taken from the atmosphere is used in the fuel burning process. First jet engines development started in the USSR before the Second World War. However, the Germans and the British are by right considered to be the pioneers in this sphere. The first turbojet aircraft took off in Germany in summer of 1939. It was an experimental Heinkel 178. 2 years later, a Gloucester jet aircraft was put on tests in Great Britain. In result of further developments in this field, both countries had serial aircraft in 1944. They took part in combat activities of the Second World War. In the Soviet Union, developments of a jet fighter started in 1941. On the first day of the Great Patriotic War, Viktor Bolkhovitinov submitted an application to the Aviation Industry Ministry on the creation of a rocket fighter interceptor. The ministry replied to have the aircraft ready within a month. Within the designated term, the experimental BI-1 rocket fighter was put on tests. The Soviet first-born jet had a classical layout pattern with a straight wing. The liquid jet engine, designed by Leonid Dushkin, developed thrust of 1,100 kilograms. Flight tests were delayed due to the design group evacuation to the Urals, and the BI-1 performed its first flight on May 15, 1942. The aircraft was piloted by test pilot Grigory Bakhchivandzhi. BI-1 managed to reach a fantastic by that time rate of climb of 82 meters per second. Without waiting for the tests to be completed, the aircraft was decided to be put on serial production. However, tests went on with great difficulties, the main of which were in connection with the liquid jet engine. The nitric acid making part of the fuel was corroding the pipelines and other elements of the aircraft construction. Any leak of this dangerous liquid threatened to turn into a fire or even explosion, and the fuel itself was enough for only 2 minutes of flight. But the trouble came from the other side. The next test flight to reach a speed of 800 kilometers per hour was scheduled for March 27, 1943. During the boost and climb, BI-1 suddenly started to dive and hit the ground. Test pilot Bakhchivandzhi died. For the first time, scientists came across a new and dangerous phenomena. It became clear that with acceleration, the air starts to act somehow differently, as if an unknown force would not let the aircraft to go through. So the aircraft needed a different endurance calculation and a different aerodynamic scheme. However, the wartime requirements did not allow to conduct the relevant research works. Without going into the details of the wreck, the fighter's production was cancelled and the non-completed aircraft were deemed dangerous to fly and destroyed. Further works in this direction restarted only in the end of the war. A rocket engine installed on experimental Lavochkin and Yakovlev piston engine fighters was used as a booster, increasing the aircraft's speed by an average of 150 kilometers per hour. An interesting idea was of a motor compressor engine, a combination of a piston and air-breathing power plant. In March 1945, such a combined engine accelerated the Mikoyan I-250 aircraft to a speed of 825 kilometers per hour. However, further works with the fighters with such power plants were deemed to have no prospects. It was clear that the future of aviation belonged to the turbojet engines, however, they were yet to be created. Developments in this direction were conducted in 1937 by designer Arkhip Lulka. However, the war that started soon did not